Hello and welcome to the next instalment of Barcodes. I'm Wayne Johnson from FIDA Solutions. There are a number of different types of barcodes that are used in the UK manufacturing and retail sector. These consist of either 1D linear barcodes, 2D data matrix barcodes, QR codes, and a variety of other different types which are used for either traceability or batch control information. I'm going to go through just some different types of barcodes that are used within those sectors. To start, we will start with EAN8, EAN13 type barcodes. EAN8 or European Article Number 8 or 13 consist of either 8 digits or 13 numerical digits. What these do is these just make sure or compare the product that is actually associated with that barcode. The reason for this is that these numbers are unique throughout the world. And the numbers for the UK and Europe actually start with a 5-digit or a 05, depending on if it's a case label. So for an EAN8 or EAN13, the retailer or manufacturer will purchase that type of barcode from GS1. That makes sure that it's to a set standard, but also that it is unique. And what then happens is if you're producing for a retailer, that retailer will supply you with that barcode number. They put that into their database, which associates that product with that unique number. When it's then scanned at the till, what that then does within their systems, it looks within the database and says, okay, that number correlates to that particular information and product, and therefore that price, etc. EAN8 and EAN13s are called 1D linear barcodes. They are made up of a number of black, thick and thin lines, and also white, thick and thin gaps, spaces. The number of gaps and the number of spaces correlate to the number using an algorithm that has been initially generated, the human readable number. And all that happens is when you generate a barcode, and you can generate them online, the retailer will generate that number. It has a unique check digit at the end which correlates from all the other previous number. So for example, in EAN8, the first 6 digits correlate to the product, and then the final 8th digit is the checksum digit derived from the other 7 numbers. Exactly the same for an EAN13. The 13th digit is the checksum digit. The next type of barcode that we will be looking at would be a code 39 or a code 128 or a UPC. A UPC is a unit part code. These are still linear barcodes, but the difference is a code 39 and a code 128 can contain alpha and numeric characters. So for example, you can put in a name or a logo, a name and number. And the code 39 and code 128 are usually barcodes that are used within factories and within systems for traceability, batch code ID on a product. So you would use that internal code, that could be 00001, 002, etc., a rolling number, so that you can then track and trace batch code of raw materials throughout a site, through a system. A UPC, a unit part code, is predominantly used now for catchweight products. So within a Catchweight product, the overall numbers or length of barcode is a 13. But what you will have is the first start of that barcode will be an 8-digit number. That 8-digit number correlates to the unique coding of that product. So that's the product ID. What you will then have is the price within that product. So when the product actually goes over a weigh scale, they know within the system the pounds per kilo, the price per kilo, etc. for that particular product. It then gets weighed, and it will then automatically calculate the weight of the product and the price associated with that from the price per kilo information. So the last part of that barcode will then be the price, which is usually pounds, 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 pence, pence. So 5 characters, and then the final character will be the check digit, which is associated with all the other information. These are predominantly on meat, on cheese products, and any other Catchweight products that can be used. The next type of barcode, or 1D linear barcode, would be something like an ITF 14 or an EAN 128. These are 1D linear barcodes, but predominantly used for case information, so final goods dispatch case information. ITF is interleave 2 of 5. The interleave 2 of 5 type barcode is a 14-digit number, and that again correlates to the retailer's information within their database. So when that barcode is scanned, it will then tell them within their database, within their stores, depots, what that product actually is and correlates to, and probably how many packs per case, etc. An EAN 128, a European article number 128, is exactly the same, except the final part of that barcode actually contains the date code information of the product. So the first part of the barcode will consist of the unique product code. It will then consist of a date code, and the way that you actually split up is called application identifiers at the beginning of those pieces of section information. So the barcode, the unique barcode information, will start with a 01 at the beginning in brackets. You'll then have the barcode information. There will then be a bracket 15 or a bracket 17, dependent on whether the date code information is a best before date code or whether it's a display until code. Those are extremely important to make sure that you get the right barcode information in those to correlate when it's then scanned within depot of the right date code information. Because the display until date, if you're still producing a display until date on the product, or the use by date may be different. Therefore, you need to make sure that when it's actually scanned, the correct application identifier has been applied. For example, if you actually put an application identifier of 15, but the best before date is entered as the human readable or within the barcode, when it's then scanned, you may be expecting, or the retailer may be expecting, a 15 code within that or a 17 code, and therefore it's incorrect. We go into a bit more detail within that information when we go through the common errors and common issues seen. A new type of barcode, although it has been used for some time, but is only starting to appear on the shelves at the moment, is what's called a stacked data bar. Now, a stacked data bar is a 1D linear barcode, but are 3 1D linear barcodes stacked on top of one another. They can be in a continuous line, but usually they are stacked on top of one another to create space and so that it will actually fit on the packaging. Now, the idea behind the stacked barcode is that it actually gives you much more information about the product. So not only does it give you the part code of the product, so the unique identification of the product, it also gives you batch code information and date code information about that product as well. So when it's actually scanned through the till, or whether it's actually scanned in store as checks, not only can they actually say, yes, that's the product that I've just scanned and I've got 10, 20, 30 of those products, they can actually identify the batch information that's associated with that product and the date code. So therefore, within their systems, that starts to become much more clever to actually reducing waste within the stores, because they then know stock rotation, they then know how many they've got left, etc., to actually move that through. The next type of barcode, which are commonly used, certainly now, and since 2005, they've certainly expanded a lot more, are what's called 2D data matrix barcodes. Now, 2D data matrix barcodes are small squares made up of a number of dots and spaces within that barcode. The idea behind the 2D data matrix barcode is predominantly on the packaging for a validation to make sure that it's the right packaging to the right product. And it was a method and a way of actually stopping and putting automation into a system to make sure that you've actually packed and you are using the correct labels. These have now been instigated a lot by a lot of the retailers to put that security in to make sure that we are actually packing with the correct information and correct labels. The wrong information, wrong labels is the biggest cause of a product withdrawal, due to allergen information being incorrect or meat in a vegan product, etc., etc. The type of barcode that would be used is an ECC200 data matrix. Now, the data matrix, the 2D data matrix barcode, the way it's actually made up with a number of dots is dependent on how many characters you actually want within the system. So if you just wanted 6 digits, 6 numbers, it is a 10 dot by 10 dot size barcode. That size of barcode can be still scannable and readable at 4 millimeters square in size, or it can be expanded to slightly larger because then it makes it easier to actually read. The standard at the moment is around about 10 millimeters in size on a pack, but that can vary depending on the size of the packaging that you have to actually read and how close the barcode scanner can actually get to the packaging to actually read it. With a 10 dot by 10 dot barcode, the maximum size that you can have within that is 6 characters, 6 numerics. So 1, 2, 3, 4, 5, 6, for example. If you wanted alpha characters within that, so letters, one letter takes up 2 spaces within that barcode. So for instance, in a 10 dot by 10 dot size barcode, you would only be able to put 3 letters, so A, B, C, because each letter takes up 2 spaces and you've only got 6. If you want more information, so you want more numbers, then the number of dots would then have to increase accordingly. So, for example, a 12 dot by 12 dot barcode can take 9 numbers, or a combination of letters and numbers to equal 9. You can then extend that to a 14 by 14 digit, where you can then have up to 25. Now, the size of the barcode can keep growing and keep growing if you want more information within that size. If you want to use it as a validation on packaging, though, there becomes a limit to the size of the barcode that will physically fit onto the packaging. So just be careful about the size and the numbers and information that you actually want to put into it. The advantage with this type of barcode is that they are very robust. So therefore, if it is scratched or a corner is missing off this type of barcode, it can still be read by the scanners that are online, because the algorithms within those scanners, cameras, are much more robust to actually read that type. What you also see is a dark line on two of the edges of that barcode. The dark lines within that barcode are there to actually give you a reference point of the orientation of that barcode. So when a scanner actually looks at it, it then knows its orientation, so then it can start reading the information associated with that barcode. Another type of barcode, again, which is a data matrix type and is very easily confused, and please don't get these confused, is what's called a QR code. Now, a QR code, as you can see from the examples, is a square barcode made up of dots as well, but it has 3 squares situated around the corners of the barcode. The idea behind this design of barcode is to take you to a website for information when it is scanned. They weren't designed initially for validation of packaging. Now, a lot of people, and certainly a lot of printers, do get these mixed up when they're asked to actually put a 2D code onto the packaging. For validation purposes, they actually put a QR code on. Now, the problem with that is that some systems that you can buy to validate the barcodes in your packaging can't actually read the QR codes, and therefore it would come up as a no read, because it would be expecting to read the 2D ECC 200 type of barcode, as we discussed earlier. Some systems can use the QR codes, so it's well worth asking before you go down the route of looking for a system on the market, can it actually read a QR code, and what are you actually using that QR code for? If it's for a design, and marketing purposes, what you can do is actually put a unique code at the start and then a website information at the end of that barcode. So you could use it for 2 different purposes on the same type of packaging. But remember, not all systems can actually cope with that, and it's well worth asking at the time. Otherwise, you could inadvertently produce lots and lots of packaging that your system can't actually scan. The final type of barcode, which again is a linear type barcode, is what's called a Pharma code. Now, a Pharma code is consisting of a number of lines. And as the name described, Pharma, it was first originated for pharmaceutical. It's used to actually identify usually the packaging. So again, it's a validation tool to make sure that you're using the right packaging. The only problem with Pharma codes and the way they're actually constructed is if you read it in one direction, so the barcode is as it should be and as you want it on the packaging, the scanner will read it and it may come up with 1, 2, 3. If you turn that barcode upside down and read it again, it can actually be read as 3, 2, 1, because it will actually read in both directions for that type of barcode. Now, fairly, they do work, they are on packaging, and they are used on a number of packaging to actually validate to make sure that they are correct. But please be aware that that is the case and what actually happens with those types of barcodes. Thank you very much for your time during these videos. Please have a look at our other videos on our YouTube channel, which go into either more detail or verification or different sections about barcodes that are used in the UK retail and manufacturing sector.